We had started with theorem 10.8, also called as degree measure theorem. You have to prove that the angle subtended by any arc of a circle at the center is double the angle subtended by the same arc at the remaining part of the circle. So we have considered a circle with center O. Arc is PQ. So we have three possibilities that our arc could be a minor arc, it could be a semicircular arc, it could be a major arc. The angle subtended by arc PQ at the center is POQ, and since point A is on the circumference, excluding the arc वाली साइड पे मैंने पॉइंट ए नहीं मार्क किया, मैंने दूसरी तरफ मार्क किया है. So the angle subtended by the same arc at the remaining part of the circle is angle PAQ. The relation that I want to prove is the central angle is twice the angle at the circumference. So angle POQ is twice angle PAQ. That is what I want to prove in each of these cases, whether or not, irrespective of the fact what type of arc PQ is. It could be a minor arc, semicircular arc, or a major arc. The result stands true. The angle at the center will be equal to twice the angle at the circumference. So the first step we want to perform here is we want to join the point on the circumference to the center and extend it a little. So if I just ignore this, let's see, this is how actually the figure looked like. And after doing the construction, I have this. So joining point A to point O and extending it a little. And the same thing is to be done in all three figures. So you have to show the construction in 1, 2, 3, each of the circles. So I'm going to do the same here. I'm going to do the construction in each of the three figures. Join point A to point O and extend it a little. And I'm naming the ray as AB. And once you've done this, I will just try to ignore the circle and I'm going to focus on the two triangles that are formed here. So let's write down what the construction is, then we'll see. So I have joined point A to point B, point O, and produced it up to a point B. And now I'm going to have the same circle. I've just copied it here. So I'm going to ignore the circle. I'm going to focus on the triangles that I have. So I have got this triangle on one side and from the other side. Let's just do it side by side so that it's easier to see. So I have these two triangles. I think you can all see it on the screen now. These are the two triangles that I have because of that construction I did. Now in each of the triangles, if you observe, I have two sides as the radii of the same circle. So in this triangle AOP, OA and OP are the radii of the circle. This makes my triangle isosceles. And because the triangle is isosceles, the angles opposite to equal sides will also be equal. This is something we were discussing when the class got over. So because of my triangle being isosceles, the two angles that will be equal to each other will be these two. Angle number 1 and angle number 2. Is that right?
Yes, ma'am.
Yes, ma'am.
What I'm going to do is I'm going to assign a value to each of these, which I usually prefer. So I'm going to say that angle 1 and angle 2 each is equal to x. With the help of these two angles, I'm going to find the exterior angle formed here. Using the exterior angle property of the triangle, I would like to find this exterior angle BOP formed at point O. And this will be
2x.
equal to, yes, this will be equal to sum of angle 1 and angle 2. This will be 2x. Similar thing will be done in this triangle. I have got isosceles triangle. OA and OQ are the radii of the circle, making my triangle isosceles, and the angles opposite to equal sides will be equal, which will make angle over here and over here equal to each other. Let's name these as 3 and 4. So angle 3 will be equal to angle 4. Again, I would like to give them a same value. Let's say each of these equals to y. And then with the help of these two angles, I want to find out this exterior angle. This will be equal to the sum of interior opposite angles 3 and 4. This comes out to be 2y. Now, if I combine these and go back to the original figure, keeping in mind what I have here, I like to go back to the original figure that I had. This one, I just marked this angle as x and this angle as 2x. On the other side, I marked this angle as y and this angle as 2y. Now, can you tell me what will be angle PAQ?
X plus y.
This is angle at the circumference. The value for this angle comes out to be x plus y. And observe what is the value for angle POQ.
2x
plus 2y.
2 common x plus y. That's correct. 2 common x plus y. Now, do you see the relation we wanted to prove? The angle at the center is twice the angle at the circumference.
Yes, ma'am.
So this is what we are going to write down. Anyone who has questions before we write down this, what we just discussed? The same proof is applicable to the remaining two circles as well. You can do the same thing in figure number 2 and figure number 3 as well. You will have the same relationship. So we will be writing this down, and you don't have to write down like for the second triangle, you can write down similarly for that. We will be proving for the first one. Anyone with questions? So let's just write this down. You can draw these triangles if you want for your reference. So these are the radii of the circle. These mean angle 1 and angle 2 will be equal. And after this, we are going to consider the angles between which we want to prove the relationship. Consider angle POQ and angle PAQ. Try to observe their values. Angle POQ is made up of angle number 1 and angle number 3. The values assigned to these are X and Y respectively, whereas this is made up of POB and QOB. I'm sorry, I just mixed that up. POQ is formed of POB and BOQ. This is 2x and 2y. We just obtained the values for these. And this is made up of angle number 1 and angle number 3, the angles at the circumference. And this can be written as twice of angle PAQ. Anyone with questions here? Anyone who's writing down, should I wait?
No, ma'am.
So you can just mention one more thing after proving your result, that in third case where your arc is a major arc, the central angle becomes a reflex angle, and then the relationship is written like this. This is again the angle at the center, right here. This is the central angle, but in case PQ is a major arc, the central angle will be a reflex angle. The result is the same. The central angle is twice the angle at the circumference. Or you can use it the other way around. The angle at the circumference will be half the angle at the center, depending on अगर हम application based question कर रहे हैं तो हमें क्या find out करना है. If we want to find out the angle at the center or we want to find out the angle at the circumference, this too can be transposed to the other side. Just remember this, or you can just use it as such. Next result, very important. Theorem 10.9, repeatedly used in application-based questions. Angles in the same segment of a circle are equal. Now here the segment actually means the part of the circle which is obtained when you draw a chord. So if you have a circle and there is a chord for the circle, let's say the chord is PQ. Now PQ here is the chord, but you can also say we have arcs PQ formed, a minor arc and a major arc. You can mark angles or try to show the angles. The arc PQ will subtend at the points of the two arcs. Let's say there are points A, B, C on this side and X, Y, and Z on this side. So I'm just trying to find out the angles subtended by PQ on the major arc. Those will be in the major segment. And the angles subtended by arc PQ in the minor segment or on the minor arc. So if I had to observe, Let's look at a relationship between only these two angles, angle PAQ and angle PBQ. The result or the theorem states that these two angles will be equal to each other. Angle PAQ will be equal to angle PBQ. This is what the result states. And if you have angles on the other side of this chord, then those angles will be equal. If you consider angle PXQ or you consider angle PYQ, maybe PZQ, all these angles will be equal to each other. The ones on the minor arc, their measures will be equal. The ones in the major segment or on the major arc, they will be equal. And this actually can be concluded with the help of the degree measure theorem. If we mark the center of this circle as O, let us just ignore everything else for the time being here. So right now I've got arc PQ subtending angle PAQ at the center. And if I wanted to use my degree measure theorem, what would the relation be?
POQ equals to twice of PAQ.
By degree measure theorem, angle POQ equals to twice angle PAQ. This is what my degree measure theorem states. But since since B is also a point on the circumference, I could have used degree measure theorem on this point as well. मैं same theorem इन दोनों पे apply कर सकती हूँ if I just ignore this. Now consider arc PQ, the angle subtended at the center and the angle subtended at the circumference, and now write down what the relation will be using degree measure theorem. So using degree measure theorem, I obtain that angle POQ equals to twice angle PBQ. I have two values for angle POQ. Central angle POQ की दो values मिली हैं मुझे. क्यों मिली हैं? क्योंकि मेरे पास circumference पे दो angles बन रहे थे. Combining the two results, can we say that angle PAQ is equal to angle PBQ?
Yes, ma'am.
And if there were any other point on the same side, let us say if there was a point C here, even then, the third angle formed here will also be equal to these two. PAQ, PBQ, PCQ, these will all be equal. Similarly, we can prove the result for the minor arc or the minor segment. This is what we understand or what we mean to say when we say angles in the same segment of a circle are equal. I hope it's clear. Usually the chord is not there. हो सकता है कि आपके जो figure दी हुई है आपको उसमें chord ना बनी हुई हो. So even when the chord is not there, you can identify which of the segments will be your major segment and which segment will be your minor segment. And if the points are on the circumference, on the major segment or on the minor segment, then the angles subtended at those points will be equal. With the help of the same result, one more conclusion can be drawn. This one, again, very important, used in questions repeatedly. Angle in a semicircle is a right angle. If you consider the theorem that you just did, PBQ, no. You need to take the angles on the same side, not on the opposite sides. PBQ is on the major segment or the major arc. PYQ is on the minor arc. They will not be equal. The angle at point A, B, and C, those will be equal because those are on the major arc. If you take the other side, the angle subtended at X, Y, and Z, those will be equal separately. If we go back to the theorem that we just did, I would like you to consider this one. Let me just go back to the proof where I have written this. So consider this particular part, second one, where PQ is a diameter. We are talking about angle in the semicircle. We just proved a result. So I'm just going to ignore this. Let's write the relation between the angle at the center and angle at the circumference for figure number 2. What will you have?
Angle POQ
Angle
equals to
POQ is
twice
equal
of
twice angle
PAQ.
PAQ.
But what about angle POQ? Since PQ is diameter,
180 degrees.
It is equal to 180
180
degrees.
degrees.
equal to 180 degrees. With the help of this relationship, what we observe is that angle PAQ is
PAQ is
90
90
degrees.
degrees.
so this angle here is 90 degrees. Every time you have a semicircle, semicircle के ऊपर कोई point है, and we are trying to find out the angle subtended at that point by the diameter. The angle at the circumference will always be 90 degrees. Keep in mind, जो ये angle बन रहा है, this angle is subtended by the diameter itself. डायामीटर के एंड पॉइंट्स को जब आप सर्कमफेरेंस वाले पॉइंट से ज्वाइन करते हो, तब जो एंगल बनता है वो 90 डिग्रीज बनता है. You cannot just take any point and join it to A and say कि ये circumference, ये angle semicircle में है तो ये 90 degrees होगा. Semicircle का मतलब होगा you are connecting the end points of the diameter to a point on the circumference and the angle then formed will be equal to 90 degrees. After that, we have another conclusion here, theorem 10.10. If a line segment joining 2 points subtend equal angles at 2 other points lying on the same side of the line containing the line segment, the 4 points lie on a circle, they are concyclic. So quite a long sentence going on here. So what it simply means is, अगर आपके पास कोई line segment है, let's say you have a line segment AB, this line segment subtends equal angles at 2 points which lie on same side. So you can either take 2 points above AB or you can take 2 points below AB. So I'll just take point C here and point D here. So angle subtended by AB at C means angle ACB. This angle is equal to the angle subtended by AB at D. Agar aisa ho raha hai, if this is happening, then what we can say is that these 4 points will be concyclic. Concyclic means these 4 points will lie on the circumference of the same circle, or we can say we will be able to find a circle passing through all these 4 points. There will be a circle which passes through all of these points. 4 points lying on the circumference of a circle are said to be concyclic, the points which lie on the circumference of same circle. And with the help of this, we have a concyclic quadrilateral, a cyclic quadrilateral. The points which are concyclic, if they are joined in order, A, B, C, D को अगर हम order में either clockwise or anti-clockwise join कर दें with the help of line segments, the quadrilateral obtained is called a cyclic quadrilateral. तो इस केस में अगर मैं join कर देती हूँ, A and B are already joined, B and D are already joined, D को C से join कर दें, तो ये जो quadrilateral बन गया आपके पास, this will be a cyclic quadrilateral. So this is what you have, and there are 2 more results which are applicable to cyclic quadrilaterals. We will be using in questions. The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degrees. आपके पास वैसे quadrilateral के 4 angles का sum होता है 360 degrees, लेकिन अगर आपके पास cyclic quadrilateral है, the sum of the opposite angles will be 180. So if you have a cyclic quadrilateral, means there are 4 points lying on the circumference of same circle. ABCD here is a cyclic quadrilateral. The sum of its opposite angles will be equal to 180 degrees. Pair A and C, they will be supplementary, and pair B and D will be supplementary. Always. And this is also true conversely. If there is a quadrilateral for which the sum of opposite angles is 180 degrees, then the four vertices of that quadrilateral will be concyclic, or you can say that the quadrilateral itself is a cyclic quadrilateral. Again, we are discussing terminology, but it's important when I write down the answers, I will be mentioning these words. So it's important that you understand what a phrase or a word would mean, or what's the importance of that. Keeping this in mind now, if you look at a rectangle or a square, in a rectangle, the sum of opposite angles is 180 degrees. In a square, the sum of opposite angles is 180 degrees. Then that means that a rectangle and a square are always cyclic quadrilaterals. Means you can always draw a circle passing through all four vertices of the square or the rectangle you have. Anyone with any questions at this point before we start with the
Ma'am, can you please explain this theorem again?
cyclic quadrilateral?
Yes, ma'am.
अगर आपके पास क्वाड्रिलेटरल है जिसके वर्टिसेस सर्कल की सर्कमफेरेंस पे लाई करते हैं, लेट्स जस्ट टेक दिस फिगर हियर. In this figure, can you see we have quadrilateral ABCD? When I say these points are concyclic, this means the points lie on same circle. अगर ऐसा हो रहा है, आपके पास कोई क्वाड्रिलेटरल है और उसके वर्टिसेस कंसाइक्लिक हैं, सारे वर्टिसेस सेम सर्कल पे लाई करते हैं, इन दैट केस वी से दैट द क्वाड्रिलेटरल वी हैव इज अ साइक्लिक क्वाड्रिलेटरल. And when this happens, when you have a cyclic quadrilateral, ऑपोजिट एंगल्स का सम 180 डिग्रीज होगा. तो आपके पास एंगल्स जो बन रहे हैं इस क्वाड्रिलेटरल में, ये चार एंगल्स बनते हैं, ए बी सी एंड डी. यू कैन टेक देम इन पेयर्स, टेक द पेयर्स ऑफ ऑपोजिट एंगल्स. दैट मींस ए एंड सी, इनका सम 180 होगा. डजंट नेसेसरीली मीन ये आपस में इक्वल होंगे. हो सकता है ये दोनों इक्वल हो सकता है एक एक्यूट हो और दूसरा ऑब्ट्यूस हो, but the sum will always be 180 degrees. And similarly for the other pair also the sum will be 180 degrees. यहाँ पे तो नजर आ रहा है हमें कि हमारा जो क्वाड्रिलेटरल है वो साइक्लिक क्वाड्रिलेटरल है. Sometimes you have to identify, like let's just consider this particular example or figure here. What do you think about this quadrilateral? Quadrilateral PORQ. Is it a cyclic quadrilateral?
No.
Because
Because O is not.
That's correct. If it were on the circumference, then we could say, like, let's take this figure here. If I join point A and D and I ask you what type of quadrilateral is ABCD, is it cyclic?
Yes, ma'am.
And
Yes,
in this case,
Yes, ma'am.
In this case, you could write down that the sum of opposite angles is 180 degrees. अगर आप identify कर लेते हो कि quadrilateral cyclic है, you can use the property that sum of the opposite angles will be 180 degrees. I hope it's clear now.
Yes, ma'am.
और अगर आपको प्रूव करना है कि कोई क्वाड्रिलेटरल साइक्लिक है, अगर हम प्रूव करना चाहते हैं, we can just prove that the sum of the opposite angles is 180, then we can say that the quadrilateral is cyclic. That's the last theorem that we had. तो हम कन्वर्स यूज कर रहे हैं. अगर आपको पता है क्वाड्रिलेटरल साइक्लिक है, you can use that sum of opposite angles will be 180 degrees. But if you want to prove that a quadrilateral is cyclic, you would prove that the sum of opposite angles is 180 degrees. Now we have questions, and this is the only exercise which has the most application-based questions from the whole chapter. First question here, we have points A, B, C on the circle. There is a point D also on the circle. Angle BOC is 30 degrees. Angle AOB is 60 degrees. D is a point on the circle other than arc ABC. So this means D is a point on remaining part of the circle. We shall be using degree measure theorem here. You have to find out angle ADC.
45 degree.
45 degree.
We are talking about this arc. Identify the angle, this arc ABC. उन्होंने indicate किया हुआ है arc का name. This is actually quite helpful. Usually हमें खुद identify करना पड़ता है कि हम कौन सी arc की बात करें, because बहुत सारी arcs बन रही हैं यहाँ पे. हम खुद identify करते हैं कि कौन सी arc central angle और circumference पे दोनों जगह पे angle subtend कर रही है, तभी degree measure theorem use हो सकती है. So first thing we would like to do is we would like to identify the arc which is subtending an angle at the center as well as it is subtending an angle at the circumference. तभी हम उन दोनों angles का relationship लिख सकते हैं. यहाँ पे उन्होंने आपकी हेल्प के लिए नाम बता दिया कि ABC की बात करनी है. So the angle that this arc subtends at the center is angle AOC. And the same arc ABC is subtending an angle at the circumference. And the name of the angle is angle ADC. We can now write down the relationship between these two, that the central angle will be equal to the angle at the circumference. Do you have the measure for any of these angles?
Angle AOC is 90.
AOC is 90 degree.
Angle AOC is 90 degrees. So with the help of this equation now, you will
ADC is 45.
That's correct. Angle ADC comes out to be 45 degrees. So you don't have to write down a lot. You can simply write down that arc ABC subtends angle AOC at the center and angle ADC at the circumference. This is important that you mention that the same arc is subtending an angle at the center and an angle at the circumference. That's why we are using degree measure theorem, and with the help of that relationship, we were able to find out ADC. I'm not going to draw the figure, I will leave that to you. I'm just going to write down the answer along with you. Just write down with me. Written?
Yes, 'm.
Question number 2, you have a chord of a circle which is equal to the radius of the circle. You have to find out the angle that the chord subtends at a point on the minor arc and a point on the major arc. This figure is with question number 3. You have to draw the figure for question number 2 yourself. So let's just roughly draw a figure and see what's going on here. So we have a circle. Let's say the circle is with center O and the radius is R. Since they're talking about the length of the chord being equal to the radius of the circle, that's why I have just indicated this, that the radius is R. Now I want to draw a chord whose size is same as the radius. So let's draw a chord AB and let it be equal to R. So this is the chord AB whose length is same as the radius of the circle. You want to find out what is the measure of the angle subtended by this chord on the minor arc and on the major arc. So you would like to mark points on the minor arc and on the major arc. I'm going to take a point P. This is on the major arc and a point Q on the minor arc. The angle subtended by chord AB on point P.
30 degree.
Angle APB, that's correct. You have to find this. And the angle made by the same chord at point Q. Join the endpoints to point Q. You want to find out angle AQB.
150 degree.
That's correct. So we shall be going back to this fact that the chord is actually equal to the radius of the circle, and we would like to apply degree measure theorem here. So degree measure theorem apply करने के लिए मुझे दो चीजों की requirement है. I want to find out what is the angle subtended at the center and the angle